In the realm of science fiction, space is often portrayed with dramatic sound effects. Explosions roar, lasers hum, and spacecraft engines seem to thunder through the cosmos. However, this is one of the most widely accepted misconceptions about space. In reality, space is a near-perfect vacuum, meaning sound cannot travel through it. Without air or any medium for sound waves to travel through, no one would hear a thing, not even the loudest of explosions. This silence, though unsettling in films, is actually a blessing for astronauts. If space wasn't so quiet, astronauts on spacewalks would be overwhelmed by the deafening noise of solar storms, cosmic winds, and the many other cosmic phenomena constantly unfolding around them. Explosions in space would look vastly different than the ones we see on Earth. Without air pressure and gravity to control the force and direction, explosions would expand outward in glowing balls of light, with debris floating indefinitely until something stopped it. For any nearby spacecraft, this debris would be a significant hazard, traveling through space endlessly, creating long-lasting dangers. Another common misconception is the portrayal of comets with glowing tails streaking behind them as they soar through the sky. Most people picture comets as easily identifiable space travelers, but in reality, comets are often hard to detect. For the majority of their time, comets drift far from stars, remaining cold, dark, and frozen. They only develop their iconic tails when they come close to a star. As they approach, the heat causes the comet to form a cloudy atmosphere known as a coma and a distinctive tail. Interestingly, the tail doesn't always trail behind the comet. In fact, it often points away from the star due to solar radiation and winds, meaning that sometimes, the tail is in front of the comet as it moves. This phenomenon further demonstrates the complexity and unpredictability of these ancient cosmic travelers. One of the most thrilling depictions in space movies involves navigating through asteroid belts. We've all seen pilots dodge and weave through dense clouds of enormous rocks, narrowly avoiding collisions in dramatic sequences. While it makes for great entertainment, this portrayal is far from accurate. In reality, the asteroid belt is mostly empty space. The asteroids are spread out over vast distances, making collisions extremely unlikely. In fact, if you were to fly through the asteroid belt, it would appear no more crowded than the sky on Earth. The idea of dodging asteroids at every turn is purely a cinematic creation, but the reality of space's vast emptiness is equally fascinating. Black holes are another cosmic entity shrouded in myth and mystery. Many people imagine black holes as insatiable cosmic vacuum cleaners, constantly sucking in everything around them. However, black holes are much more passive than that. They don't actively hunt for matter to consume. Instead, they sit quietly in space, waiting for a star or object to drift too close. Only when something crosses a certain threshold, known as the event horizon, does the black hole's gravity tear it apart. Interestingly, black holes aren't fundamentally different from any other celestial object. Their gravitational pull is proportional to their mass, meaning they can only consume objects within their size limit. If, hypothetically, our Sun were replaced by a black hole of equal mass, Earth and the other planets would continue to orbit in the same way. Gravitationally, nothing would change, demonstrating that black holes, while powerful, aren't the all-consuming monsters we sometimes imagine. Space battles in films often feature colorful laser beams cutting through the darkness, but this too is a misconception. In reality, laser beams in space would be almost invisible. On Earth, we see laser beams because particles in the air scatter the light, making the beam visible. In the vacuum of space, there are no particles to scatter the light, meaning a laser beam would be virtually undetectable. Though lasers could still be powerful weapons or tools in space, they wouldn't look anything like the bright beams of red or green we see in movies. One of the most dramatic myths involves what happens to a human if they're exposed to the vacuum of space without a spacesuit. Contrary to what we see in movies, where people explode or freeze instantly, the reality is much less dramatic. If a person were exposed to the vacuum of space, they would lose consciousness after about 15 seconds due to the lack of oxygen. If they hadn't exhaled before exposure, the air in their lungs could cause internal damage, but they wouldn't explode. Without the pressure of a spacesuit, the body's internal pressure would decrease, but while it would be an unpleasant experience, it wouldn't be the immediate, catastrophic death so often depicted. However, staying in space unprotected for too long would still be fatal, but not as visually intense as pop culture leads us to believe. Another misunderstanding is the concept of zero gravity in space. Many people think that astronauts in the International Space Station, ISS, experience zero gravity, but that's not entirely accurate. While they do experience weightlessness, gravity still exists in space. The reason astronauts feel weightless is because they are in a constant state of freefall. The ISS orbits Earth, and both the station and everything inside it are falling at the same rate, which gives the illusion of zero gravity. This effect is more accurately described as microgravity, where gravity still exists but is significantly weaker than on Earth. This microgravity allows astronauts to float and move heavy objects with ease, but it's not the absence of gravity entirely, as is often believed. The term light year is another source of confusion. Many people assume a light year measures time, but in reality, it measures distance. A light year is the distance that light travels in 1 year, which is nearly 6 trillion miles. This staggering distance helps to illustrate the immense scale of the universe. Even though light travels incredibly fast, it still takes years for it to travel between stars, underscoring the vastness of space. One of the most fascinating misconceptions is the idea that the sun is always on fire. While it may look like a massive ball of flames in images and movies, the sun isn't actually on fire. Instead, it's a giant ball of gas undergoing nuclear fusion at its core. This process converts hydrogen into helium, releasing enormous amounts of energy in the form of light and heat. However, since there's no oxygen involved, the sun isn't technically burning. The energy it emits is the result of nuclear reactions, not combustion. The speed of light is often considered the ultimate speed limit in the universe. Many people believe nothing can travel faster than light, but there's one exception: the expansion of the universe. The universe is expanding at a rate faster than the speed of light. Galaxies at the edge of the observable universe are moving away from us at speeds greater than light due to the expansion of space itself. This phenomenon is still not fully understood, but it challenges our understanding of the universe and the laws of physics. Some scientists even believe that certain particles could one day be discovered that travel faster than light, opening up new possibilities for space exploration and challenging our current understanding of the universe. Stay tuned for more fascinating insights into the mysteries of space on Waves Discovery, where we explore the wonders of the cosmos and separate fact from fiction.